Alright, in today's discussion we are going to talk about factoring special products. Firstly, we're going to talk about looking at perfect square trinomials. So when we're talking about perfect square trinomials, we're talking about a trinomial. Remember, that means three terms that can be written in the form a squared plus 2 times a times b plus b squared. We can also write it as a squared minus 2 times a times b plus b squared. Now there's a way to factor this first one, and it's going to be a plus b times a plus b, which is just a plus b squared. And in the second one, it's going to be a lot of the same stuff, but we're going to change that plus to a minus. A minus b times a minus b, which is the same as a minus b squared. Now, I'm not going to really say you have to look at a trinomial and be like, oh, yeah, I can break it up into this form and do it this way. You can still use the methods we've talked about in the last two videos. Now, I'm going to, in this video, show you specifically how to use this rule. So, example 1, we're going to look at x squared plus 12x plus 36. Really, how this rule works is we ask ourselves, are we able to first look at the first term and the last term and write that as something to the power of 2? Well, x squared, that's already x squared. It's x to the power of 2. 36, well, is there a number times itself that makes 36? The answer is yes, and that's 6. So if we can now write the middle part as 2 times x squared, or 2 times x times 6. In fact, let's put the x and the 6 in parentheses. If we can write it as a squared plus 2ab plus b squared, which so far we know a is x in this case, and b is 6, if we can write 12 as plus 2 times x times 6, then we can factor this. And 2 times x times 6, that's 12x. So this means we can just use the formula that we just looked at. That means this factors to x plus 6 times x plus 6, which we can simply just write as x plus 6 squared. Let's look at another example. We'll call this example 2. Let's look at 4x squared minus 12x plus 9. So I ask myself, is there a way that I can write 4x squared like the formula, this whole expression? Can I write it as a squared minus 2ab plus b squared? So, can I write 4x squared as some expression to the power of 2? Well, we know 4 is 2 squared and x squared is just x squared. So we can write this as 2x to the 2. And we know 9 is 3 to the 2. So if we can write the minus 12 as 2 times 2x times 3, we're good. So minus, if we go 2 times 2x times 3. I just want to check, is 2 times 2x times 3 equal to 12x? 2 times 2 is 4, and 4 times 3 is 12, so we do have 12x in the center, which means we can factor this fairly easily. We're going to have 2x. Now we're going to take the minus because the plus is at the back. 2x minus 3 times 2x minus 3, which we can just simply write that one time, 2x minus 3, and then we square it. Let's look at one more. Example 3. We're going to look at x squared plus 9x plus 16. So we're going to ask ourselves, in fact, x squared, that's already as a number times itself. 16 as a number times itself is going to be 4 squared. We want to see is 2 times x times 4 equal to 9. Well, 2 times x times 4, that's 8x. That doesn't equal 9x. Which means this is not a perfect square trinomial. And in this case, we're not going to try factoring it. We're just going to say not a perfect square. Trinomial. There is one other special product, special case that we can look at. So there is this unique case where we can factor something if there's only two terms, and it's called a difference of two squares. Literally meaning two expressions that are squared. Now there are some conditions before we can look at this. It is a difference of two squares if it meets the following conditions. There are two terms, one is subtracted from the other. We cannot have an addition problem here. It has to be subtraction. And then both terms are perfect squares. So first, I'm going to give you the formula for doing this. What we can say is if we have something that can be written as a squared minus b squared, it factors uniquely. It factors to a plus b times a minus b. And it's the only thing that it can factor to. We cannot have something where it's a squared plus b squared. So let's look at an example. What we're going to do is determine if it's a perfect square or difference of squares, and then factor it if it is. So example 4, we're going to look at x squared minus 81. So first, it does have two terms, and it is just through subtraction, so we've met that requirement. Now the question is, are they both perfect squares? Well, x squared, that is a perfect square. So it's x squared minus 81. That is also a perfect square because that is 9 squared, which means when we're factoring this, we can use that formula. In this case, we have x is our a, 9 is our b. So we've got x plus 9 times x minus 9. And that's our answer. I've got two more examples I want to look at, and then we can call it good. So example 5, we're going to look at 9 p to the 4th minus 16 q squared. Okay, so first we have to ask ourselves, can we write each... Well, first there are two terms, we know that, and then we're subtracting. We're good there. Now we ask ourselves, can we write the first term as something times itself? Well, 9 we know is 3 times 3, so we'll put a 3 in there. P to the fourth, that can be p squared times p squared. So we've got 3p squared squared. Minus, okay, now we have to check the second term, 16q squared. Well, what times itself makes 16? That's 4. And then what times itself makes q squared? That's q. So we've got 3p squared squared minus 4q squared. We've got a difference of 2 squares. So our factors are going to be 3p squared plus 4q times 3p squared minus 4q. Alright, let's look at one last example and then we'll call this lesson done. So example 6. So we've got x to the 6th minus 7y squared. So first, we do have two terms, and we are subtracting one from the other. We've met that first requirement to be a difference of 2 squares. However, the second requirement is not met. We can write x to the 6th as x to the 3rd squared. However, this second term, 7 is not a perfect square. We cannot rewrite 7y squared as something squared. So this is not a difference of 2 squares, and that's all we're going to say. Not a difference of 2 squares. And that's actually going to wrap up our lesson on special products, factoring special products.